Hi everyone. So today it's Coach Fred here, and today we're going to be talking about operations and composition of functions. So some new stuff, some old stuff, and new stuff together. So I want us to remember that f of x is just another way of writing the y that we've always talked about. And we're going to now move into just really using f of x as often as we can. And remember that just helps us understand that the function itself depends on what x is. X is the independent variable, and f of x is the dependent variable or the output. So a couple of things that we're going to have to remember is our domain reminders. Remember, domains, denominators cannot equal 0, and there can be no square root of negative numbers for functions. But it is important for you to recognize some things about domains. So number one, if I'm looking at this function, I'm hoping that you see right away it's linear. And so our domain would be all real numbers because there's no limitation, there's no square root, there's no fraction. Here, unfortunately, we've got a denominator with a variable in it. So if we want to find the values that x cannot be, we set that value equal to 0, right? And we get x squared equals 16. So x equals plus or minus 4, which means that x cannot be 4 and x cannot be negative 4. So we write that as negative infinity to negative 4, parentheses, union, negative 4 to 4, union 4 to infinity. Okay, this next one's interesting. So I would press pause and try it on your own and then come back to me. If you really look carefully at this x squared plus 1, there's actually no value of x that would make the denominator 0. If you plug in 0, you're going to get 1. If you plug in negative 1, you're going to get 2. Any negative is going to become a positive, and then you're going to be adding 1 to it. So the domain here would be all real numbers. Okay, that doesn't mean that some other things can't exist, but we're just not going to get into that right now. All right, so now the two that we have to be really careful about, right? We have a square root, and so we have to remember that the value under the square root has to be greater than or equal to 0. So one way to find it is actually to set the expression that's under the square root greater than or equal to 0 and solve. Just be careful if 3 had a negative on it, it would flip the sign. So x has to be greater than or equal to 4, which means 4 to infinity. Okay, now they get harder when you have to put all of this together. So we actually have a square root in the denominator. So in this case, x minus 1, we're going to set it greater than 0 because it can't be 0 because it's a fraction in the denominator. We got to be careful. So x's have to be greater than 1. So that would be parentheses 1 to infinity. All right. This is important because we're going to look at how we can actually add, subtract, multiply, divide, and compose functions. And so we have to understand notation. So we know the operation of addition, and if I give you just two numbers or two expressions to add, you know how to do that. In function notation, we have to recognize we could write it several ways. We could say, which you might feel comfortable, f of x plus g of x. That just means add the two functions. But we could actually write it like this, and we normally do. We would say f plus g of x. That's how it's read. All right, so if I want to do it in terms of x, f of x plus g of x, I just add the two functions. So 5x squared minus 4x plus 5x plus 1. And that would give me 5x squared plus x plus 1. And that would be f of x plus g of x, or f plus g of x. Okay, with numbers, you can do it two ways. You could really do f of 3 plus g of 3, which I find to be pretty easy. Or you could add the functions together to get this and then evaluate it with 3. So either way it will work because it's addition. All right, so if I do f of 3, that would give me 5 times 9 minus 12. So 45 minus 12, which is what, 33? And I have to add to that g of 3, which would be 15 plus 1, which is 16. And so I think that's 49. All right, if I do it the other way, let's see. If I evaluate it after I add them together and just do f plus g of 3, so add the functions, and that would be 5 times 9 plus 3 plus 1, which is 45 plus 4, which is 49. So either way it'll work. Same thing is true about subtraction. F minus g of x means the same thing as f of x minus g of x. Do want to be careful though, because g of x now we see as an expression. So when we subtract, we're going to want to make sure that any expressions being subtracted from go in parentheses. Why? Because you have to distribute your negative. And so that will be what gets you. So that's going to give me 2x squared plus 3x minus 1 minus 5x minus 1. And then we combine the like terms. So 2x squared minus 2x minus 2, I think. So I think that that's actually a great problem to kind of see that negative. Now you can do it here as well. Again, you could do f of 2 minus g of 2, or you could evaluate after you subtracted the equations together. So that would give me, I'm going to do it this way. I'm just going to go into this function. So 2 times 4 minus 2 times 2 minus 2. Gosh, that's a lot of 2's. So 8 minus 4 minus 2, which is 4 minus 2, which is 2. So f minus g of 2 is 2. All right, so that's subtraction. Multiplication, same thing. F times, there's that little symbol, g of x equals f of x times g of x. So it means x squared minus 3 times x plus 5. You could leave it like that. Or you could do f of negative 4 times g of negative 4 with numbers. So plugging in negative 4, noticing I have to square it. So negative 4 squared minus 3. So 16 minus 3 is 13. G at negative 4 would give me negative 4 plus 5, which is, 1. Made it nice there. And so my answer would be 13. All right, the one we really have to be careful of is division. So f divided by g of x means f of x over g of x. So we got to be really careful because now we know that we could have a restricted value. So if I divide these, I have to realize that x cannot equal negative 1. That doesn't mean this won't simplify, because it will. I'm sorry, x, if I factor the top, it becomes x plus 1, x minus 1, all over x plus 1, and then these cancel. So I'd be left with x minus 1. But this is still a restricted value. You may remember earlier this year we called these types of functions rational functions, and we said wherever the denominator was 0, we'd have a vertical asymptote, except in one little case, and this is the case. The case is when you have a domain restriction like negative 1, and the factor actually cancels like that. It means there's not a vertical asymptote, there's a hole in the graph. There's a hole in the graph. And we'll talk about that in class, okay? All right, so if I wanted f divided by g of 6, I can actually use this simplified expression to get 6 minus 1, which equals 5. All right, so it is really important that you notice the notation here. It is new. It is something we're going to have to get used to. The next video is on composition of functions, which is slightly different as well. So these are all new ideas and new symbols we're going to have to get used to. Please write down any questions you have and bring them to class tomorrow. All right, have a great day.